Today in the workshop, we're meeting the Seeeduino XIAO family. You'll see how there are now over a dozen XIAO boards, each with its own unique features. We'll also see how we can use the same circuit to create 3 very different projects using different XIAO boards. It's a Seeeduino XIAO reunion, so welcome to the workshop. Well, hello and welcome to the workshop, and today we've got a bit of a family reunion going. It's the Seeeduino XIAO family. Now, the Seeeduino XIAO is nothing new to those of you who've seen the DroneBot Workshop before. I've used Seeeduino XIAOs in a number of different projects. I did a dedicated video about the original XIAO, as well as the ESP32S3 Sense board, which is a Seeeduino XIAO that comes with a camera board. But there are many, many more Seeeduino XIAOs. In fact, at the moment, there are a dozen different models of the XIAO. Now, the XIAO is a very high quality yet very inexpensive microcontroller. All of the XIAOs have the same footprint, so you can use the same prototyping devices with all of these different processors. So it's a really great way to work with electronics. Now, today what we're going to do is we're going to take a look at all of the different family members. We're also going to take a look at some of the prototyping tools that you can use with the Seeeduino XIAO, and we're even going to take a peek at some other boards that are equivalent to the XIAO. So let's go and start off by taking a look at the Seeeduino XIAO family. The Seeeduino XIAO family consists of a number of small microcontroller boards that have multiple processors. All of the boards in the XIAO family have the same footprint and use the same USB-C connector. The XIAOs are high-quality boards, they are low cost, and they're very commonly available at most distributors. The Seeeduino XIAO is available with a number of different microcontrollers, and we'll be taking a deeper look at these in a few moments. All Seeeduino XIAOs feature a common pinout with a 5-volt input, a ground, and 3.3 volts on the same pins. The XIAOs use castellated pins, which allow them to be both surface-mounted or mounted on a circuit board or solderless breadboard. Pins D0 to D10 are multifunction I/O pins, and on different XIAOs they have different uses. The XIAO boards are packaged with the pins, but they aren't soldered, allowing you to use them on a solderless breadboard or to surface mount. There are also extra connections on the bottom of every XIAO board. All of the XIAOs have a connection for a rechargeable battery. The other pins will vary between models, and they depend on the type of microcontroller on that model of XIAO. You can attach to these pins using a surface mount connection, or you can use pogo pins if you want to put the XIAO in a socket. With a wide variety of microcontrollers and features, there's sure to be a Seeeduino XIAO that'll fit perfectly into your next project. So let's go and take a look at the Seeeduino XIAO family. And here I have an assortment of Seeeduino XIAOs, different types of XIAOs and different types of packaging that they come in as well. The Seeeduino XIAO is typically packaged in one of these little packages. It almost looks like something you'd see at the supermarket checkout. And now they're transitioning to this round package where they give you the XIAO and underneath they package all of the pins. It doesn't matter what package you get, the product is the same. They're going through a transition period right now. Up over here I have a kit that they're providing. It's one of several different kits that Seed Studio provides that use the XIAO, and this is a mesh-tastic kit. So it has this, I've got one open here, it's got a little LoRa board in it and a couple of antennas, as well as a Seeeduino XIAO ESP32S3 board, and this board piggybacks on top of that board. So I've got 2 of these, and this is sort of a teaser. You'll be seeing these in a future episode of the DroneBot Workshop. I've got a few XIAOs over here in various states. This is the way that they come right out of the box. They come without the pins soldered in, and you can flip it over and see that they've also got some pins on the back as well. Here's another one that's got more pins on the back of it. You can also solder pins onto it, so I've got pins soldered onto this one. Here's a XIAO that's got a camera on it. This is the ESP32S3 Sense board, and the Sense board on top has a camera and also a microphone. We'll be taking a closer look at that in a few moments. But as you can see, there's a wide variety of boards that you can get in the package of the Seeeduino XIAO. Now we're going to experiment with a number of the different XIAO boards, but we're going to use the same hookup for all of our experiments. And so we will start with the Seeeduino XIAO. The model of XIAO will depend upon the experiment that we're doing. We're also going to need a 10K potentiometer, a linear taper pot, an AHT20 temperature and humidity sensor, an LED, you can choose any color you like, and a dropping resistor for the LED, I'm using 220 ohms, and an SPST push button. We'll begin by connecting the 3.3 volt output of the Seeeduino XIAO to one side of the potentiometer. We'll connect the XIAO's ground to the other side of the pot. The wiper of the potentiometer will be connected to XIAO input A0. We'll connect the XIAO's 3.3 volt output to the V-in on the AHT20 temperature and humidity sensor. And we'll connect the XIAO's ground to the ground on the AHT20. We'll connect the SCL pin on the AHT20 to pin D5 on the XIAO. And we'll connect the SDA pin to the XIAO's pin D4. We'll ground one side of our push button, and we'll connect the other side of the push button to XIAO input D1. Finally, we'll connect XIAO pin D10 to one side of the 220 ohm dropping resistor. The other side of the dropping resistor will go to the anode of the LED, that's the long lead on the LED. And we'll finish by connecting the ground to the cathode of the LED. And this completes the wiring that we're going to be using for all our Seeeduino XIAO experiments. So as you've seen, there are quite a few Seeeduino XIAOs, and to cover each one individually would make this a very, very long video. I probably will be doing a video on some specific XIAOs a little later on, but today what I've done is I've divided the Seeeduino XIAOs into 3 different groups, and we'll handle them group by group. And so the first group are what I'm calling just general purpose microcontrollers. These are microcontrollers that don't communicate with Wi-Fi or BLE, but they're nonetheless very powerful devices that you can use for a number of different microcontroller projects. So let's go and take a look at our general purpose microcontroller XIAOs. The general purpose boards that we'll be looking at today include the XIAO SAMD21, the XIAO RP2040, and the XIAO RP2350. The XIAO SAMD21 was the original Seeeduino XIAO board, and we covered this a few years ago in a dedicated episode. It's based around the microchip SAMD21 MCU. This board is compatible with the Arduino Uno, and you can take most of your Arduino Uno sketches and run them directly on the board, making this an ideal first experimenter's board. And here's the pinout of the SAMD21. Note that many of the pins have multiple purposes. You'll also note that many of these pins are touch pins, so you can use this for touch inputs if you wish. The XIAO RP2040 is based around Raspberry Pi's RP2040 microcontroller. This is an ideal board for running MicroPython, and it's compatible with the Raspberry Pi Pico. Here's the pinout of the RP2040 board. Notice that there are some dedicated pins for MicroPython included. And the XIAO RP2350 is based around Raspberry Pi's RP2350 microcontroller. This board also supports MicroPython, and it is compatible with the new Raspberry Pi Pico 2. Here we can see the pinout of the XIAO RP2350. Now for our first demonstration, we're going to be using a XIAO RP2040. So that's the XIAO that has the processor from Raspberry Pi on it. And what we're going to do in this demonstration is we're going to use both cores of the RP2040. We're going to illustrate how we can use them independently. So we're going to read the temperature and humidity from the AHT20 in one core, and we'll display that on the serial monitor. With the other core, we'll use the pot to vary the brightness of the LED using PWM, and we will also use the push button to indicate whether the LED is either solid or flashing. So there's a lot of stuff going on here, and it's going on in 2 different cores. Now we'll start by including the required libraries: wire library for I2C, the library for the temperature and humidity sensor, and the multi-core library, and that is essential for this to work. Then we'll define the connections to the XIAO and also some operating variables for the pot value and also whether the button has been pressed. We'll define an object for the AHT20, and we go into a function called core1task, and this is the task that we're going to run in the first core. And what we're going to do is just read the AHT20 and report it over the serial monitor. So we do what we generally do with the AHT20. We create an event for humidity and temperature. We populate that if there is data there, and we print it out on the serial monitor. Otherwise, we print out that the read failed. And we're going to delay by a second. And note that we're using a delay command. Now, delay stops your microcontroller for a second in this case. You normally wouldn't do that if you're doing other things because it would stop it from servicing those other things. But in this case, we're running this in one core, and the other things we're doing will run in the other core. Now we'll go into our setup. We'll set up our serial monitor and define the pin modes for the pins that we're using. We'll set up I2C and start it. And we'll also check to see that we can start the AHT20. We'll set our resolution with analog write resolution for the PWM to 8 bits. And we'll launch the core1task with a multi-core launch core, and then we'll call that function that we described earlier. Now we go into the loop, which runs in core 0, and we're basically going to check, first of all, to see whether we're in blink mode. That's what the switch toggles, whether we are or are not in blink mode. Is the LED going to be blinking or solid? And we'll take a look and we'll see if it needs to be toggled or not. If it does, we'll debounce it, and we'll toggle the value. Over here we do an analog read of the pot, and then we map the pot value down to 0 to 1023, and map that down to a PWM value of 0 to 255. So we'll get the pot value and use it to set the PWM value. Then we'll check the blink mode, and if it's not blink mode, then we're going to do solid brightness. We just do an analog write to the LED with the PWM value. If we're blinking, we do the same thing, except we put a delay, and on the second one we just write a 0, not the PWM value, and that will flash it on and off. And so these two processes will run independently of one another. Let's load that up to our XIAO RP2040 and watch it work. And here's the demonstration of our RP2040 running two different tasks. Now you can see in the serial monitor that the AHT20, which you can see in the middle of the board, is reading the temperature and humidity. Now you can see my LED, it's the yellow one buried over here, and here's my push button, the blue one, and that'll toggle the mode. And so now I've pushed it and it's in flash mode instead of in solid mode. And the potentiometer will change the brightness of that, so I can set it down so we can hardly see it all the way to full brightness, and that's there. And I can toggle the mode again into solid mode and still change the brightness if I want to. Now note that at the same time the temperature and humidity is still going on. It's not affected by any of this, and that's because each process is running in its own independent core in the RP2040. So it's a simple demonstration, but it shows how the RP2040 can use two cores, and also shows just how easy it is to prototype things with the Seeeduino XIAO. Now the next group of Seeeduino XIAOs is the largest of the group. There are actually 6 devices here, although it's really only 4 processors because 2 of them are sense versions of the other ones. They have extra sensors on them. These Seeeduino XIAOs can communicate using either BLE or Wi-Fi. Some of them can use both. So let's go and take a look at some Seeeduino XIAOs that we can use for communications. Under the category of wireless and BLE boards, I've included the XIAO NRF52840, the NRF52840 Sense board, and the XIAO ESP32C3. I've also included the XIAO ESP32C6, the XIAO ESP32S3, and the ESP32S3 Sense boards. The XIAO NRF52840 is based on a Nordic NRF5280 microcontroller. This device is ideal for Bluetooth and near-field communications applications. This is an ultra-low powered device, so it's great for battery-powered projects as well. It's also available as the NRF52840 Sense board. This has all the features of the other board, but also includes an onboard microphone and a 6-axis inertial measurement unit. Here's the pinout for the XIAO NRF52840 boards. The XIAO ESP32C3 board is based around Espresso's ESP32C3 microcontroller. This is a low-cost board with both BLE and Wi-Fi capabilities. Here's the pinout of the XIAO ESP32C3 board. The XIAO ESP32C6 is an advanced ESP32 board with both BLE 5.0 and Wi-Fi 6. It supports Zigbee and Thread for Matter, so this is ideal for IoT projects. Here's the pinout of the XIAO ESP32C6 board. The XIAO ESP32S3 board is a powerful ESP32S3 microcontroller from Espresso. This board is ideal for BLE and Wi-Fi projects. It's also available as the XIAO ESP32S3 Sense board, and this is another board that we've done a full episode on. This board comes with an adapter board that includes a camera and a microphone. Here's the pinout of the XIAO ESP32S3 board. As well, here's a pinout diagram for the microphone and camera adapter used with the Sense board. Now to demonstrate a Wi-Fi enabled Seeeduino XIAO, I'm going to be using an ESP32C3 XIAO. And what we're going to do is we're going to create a simple web page which displays the temperature and the humidity from the AHT20. It'll also display the value of the potentiometer from 0 to 4095, and it will let you control the LED. There's a switch on the web page that'll let you toggle the LED on and off, and it displays the state of the LED. You can also toggle the LED using the built-in switch, and so that state will of course be reflected on the web page as well as toggling the LED. And so let's take a look at the code quickly. We'll include the required libraries, and these are what we would expect for a web server: the Wi-Fi and web server library. The wire library, of course, is for I2C, and the library that we need for the temperature and humidity sensor. Now this is where you're going to have to do your own configuration. I'll need your SSID and your password over here to connect onto your Wi-Fi network. Then we'll define the pins that we're using, and we'll create an object for the AHT20, and we'll set up a web server as well. Okay, we'll also set this boolean called LED on, and this is a toggle that just lets us toggle on and off the LED. Now, this string over here called HTML page, where we can pass a few inputs to, is what we're actually going to display on the page. So this is our entire HTML page, and you'll notice there are 3 inputs we're passing to it: the temperature, the humidity, and the value of the potentiometer. And we will pass those over here, as well as also putting the LED on status over here, and this will toggle as to whether that reads on or off on the web page. Now we've got a bunch of helpers down here to help things out. This is what actually toggles the LED. So this is apply LED that toggles it. This is handle root, which handles most of the root values. It takes the sensor values from humidity and temperature and the potentiometer pins, and then it calls up that HTML that we saw earlier and passes those values out to it. This is what we use for toggling the LED, and we have 2 over here to toggle. It'll handle both a post and a get, and so we do that up here. And down over here is where we handle the toggling of the LED with the local push button. So we see if the button has been pressed. We do a bit of debouncing inside here with the millis command over here. You've seen that kind of debouncing before. And we set the status of the button. Okay, in setup, we go and we start the serial monitor, set the pin modes for the LED, and we'll toggle the LED. We'll also set the pin modes for the button, and we'll set up the I2C on D4 and D5, and we'll connect to the temperature and humidity sensor. Over here, we will start the Wi-Fi and we'll connect, and as long as we've connected, we'll display the IP address, and that's important. That's going to print out on the serial monitor, and that's the IP address you're going going to need to use on a web browser from a computer or a phone or a tablet that's connected to the same Wi-Fi network. Then we set up the routes, and then we go into the loop. And in the loop, we just basically handle the client. That's what a web server does most of the time. And we also take a look at the status of the button from that function you saw earlier, and we toggle the LED accordingly, and that's if we press the local push button. So this is the code. We're going to load it up to the ESP32C3 Seeeduino XIAO, and we'll check it out. And here's my Seeeduino XIAO ESP32C3 demonstration, the exact same solderless breadboard. All I've replaced is the processor. And you'll note that I have an antenna attached to this, and that's an important thing to do. If you're using this or any of the ESP32 boards that has connections for an external antenna, and you are using the radio, either Wi-Fi or Bluetooth, we're using Wi-Fi in this case, you must have an antenna. If you don't, you won't have an unbalanced output. You could actually damage the module, and that's true of any ESP32 that uses an external antenna, by the way. But basically, here's our web page. You can see this is the page we're generating, and it gives the temperature and humidity, and also the value of the potentiometer and the status of the LED. Now, I can toggle the LED with a push button over here, so if I toggle it, you'll see on the page it says that it's on. I can toggle it again, and the page reflects the value, as does, of course, the LED. I can also toggle the LED with this switch here. So I can click that, and it goes on. And I can click it, and it goes off. So I can control the LED remotely. I can read the value of the pot. I'll turn it down, and it's down near the bottom. I'm getting a value of 10 and getting a value of 8. Now let's go all the way up to the top. And we're getting a value of 4095. Again, there's sometimes a latency or a delay here, and it's reading the temperature and humidity as well. So it does seem to work pretty well. It's a good demonstration of the capabilities of the Seeeduino XIAO ESP32C3 board. Now, the third and final group of Seeeduino XIAOs is what I'm calling the advanced ones. And there are 3 boards here, but once again, one is a sense version of the other board, so there's really 2 processors. These boards are great for IoT applications and for low power applications. So let's go and take a look at the advanced Seeeduino XIAOs. In the category of advanced MCU boards, I'm including the XIAO RA4M1, the XIAO MG24, and the XIAO MG24 Sense. There are also 2 new boards that have just come out, and I'm adding those to the list as well, the XIAO NRF54L15 and the NRF54L15 Sense boards. The XIAO RA4M1 is based upon a Renesas RA4M1 MCU. This is a 48 MHz Cortex-M4 and is compatible with the Arduino Uno R4 in software. Note that the pins on the XIAO are 3.3 volts though, whereas the Uno R4 is a 5-volt microcontroller. Here's the pinouts of the XIAO RA4M1. The XIAO MG24 is based upon a Silicon Labs EFR32MG24 microcontroller unit. This is an ultra-low power consumption unit, and it supports BLE and Thread for Matter, so it's ideal for IoT projects. The MG24 Sense adds an onboard microphone and a 6-axis inertial measurement unit. And here's the pinouts for the XIAO MG24 series. And now our new board, the XIAO NRF54L15. It's based on a Nordic NRF54L15 microcontroller. This is an ultra-low power device that has BLE and Thread for Matter and also supports Zigbee, so it's an ideal device for IoT applications. It's also available in a Sense variety that includes an onboard microphone and a 6-axis IMU. And here are the pinouts for the new XIAO NRF54L15 boards. And for our advanced MCU demo, I'm going to be using a Seeeduino XIAO MG24 Cents board. Now, this is the Silicon General board that also has a microphone and an IMU on it, and we're going to look at the IMU values. We're going to read them, we're going to display them, as well as calculate a value for motion, which is derived from all three values. We'll also read the AHT20 temperature and humidity sensor, as well as the potentiometer values. And again, everything will be placed onto the serial port. Now, when you go to use this board the first time in the Arduino IDE, you'll be prompted to install some Silicon General files. You'll need to do that and let the IDE do it. It does take a little while too, so run away and have a coffee or something and wait for it to do that. Once you've done that, you can start working with the board. We're going to start by including the required libraries, the wire library for I2C, the library for our temperature and humidity sensor, and the library for the IMU, and make certain that when you're looking for this, you get the Seed Studio library. There is also an Arduino one. You don't want to install that. You want the Seed Studio one. We'll create objects for both the IMU and the temperature humidity sensor, define the pins, and when you're defining pins for the MG24, you can't use things like D10, A0, etc. It'll fail to compile. You have to just take the letters off and use the numbers. We'll also just define a Boolean for the LED. Now in the setup, we're going to set up the serial monitor, do the pin mode, the usual thing. We'll start the wire library, and we'll start both the IMU and the AHT20 sensor, and we'll make certain that they start, and then we'll print out that the demo is going to start. Now, the push button will toggle whether the LED is enabled or not. We'll read the potentiometer, we'll read the sensor here, and we'll read the acceleration from the IMU, and we'll calculate motion this way, and this is what motion is basically being calculated as. And then we'll print everything out to the serial monitor. And the logic of the LED is basically if the motion is too high, is over 2.5, the higher the value, the more motion there is, the LED will come on, otherwise it'll go off. So the LED can be used sort of as a detector for something that really gets bumped or moved. We'll put a little delay at the end, and that's the end of our sketch. So let's just load it up and watch it work. And here we have our MG24 Cents demonstration. I've just replaced the processor on the board with the MG24 Cents. And you can see on the serial monitor, we're reading things like the potentiometer, temperature, humidity, acceleration on 3 different axes, and the motion. If I move our board around, we can see that that motion and the acceleration values change. And if I move the pot, you can see its values change too. So once again, we've managed to get this board working very easily thanks to the Seeeduino XIAO environment. It's very easy to use, and we can use very sophisticated boards with exactly the same hookup. Now, one wonderful thing about the Seeeduino XIAO series is that every board has the same footprint. They have the same power requirements and the same pinouts. So you can essentially swap one Seeeduino XIAO for another one. And this means that any prototyping tools and accessories that you buy for one XIAO can be used with all of them. So I'm going to show you a few of the prototyping and accessory tools that I've collected over the years for the Seeeduino XIAO. Now here is just a very small sampling of some of the many accessories that Seed Studio has for the Seeeduino XIAO, and of course you can use these with all the different models of XIAOs. Now over here on the left I've got one that I've plugged the XIAO into, and this one goes out to a bunch of Grove connectors. Now Grove connectors are a bit like quick connectors in the sense that they can carry I2C, but they can also carry other things too. There are Grove connectors for UARTs, there's Grove connectors for analog signals, Grove connectors for general I/O signals, and all of them are broken out over here, and you can connect other modules to it. And this is a great way to prototype without having to actually do any wiring or even use a solderless breadboard. You can get all kinds of I/O modules that connect via Grove connectors. You can also get accessories that connect those to a solderless breadboard if you need a solderless breadboard for something specific. Over here on this end, we've got one that's really interesting. This is a round display, and on the back of it you see you can mount a XIAO, and I've got a XIAO on here. It's got a place for a battery. It's got a place for a micro SD card, and so you could build a complete product basically without doing any wiring. Pick the XIAO that's suitable. It's also got a connector on the front for an external battery as well, so you can do a lot of things with a product like this. And this is one of my very favorites over here. In fact, I've got a few of these. This connects to XIAO, and right beside the XIAO you can see they've left some pins, so you can get a pin to every one of the IOs. You've also got the Grove connections. They've integrated a couple of push buttons onto the side over here. You can see the OLED display. There's a real-time clock. There is a connector for an external LiPo battery that'll get charged. On the back over here they have a battery backup for the real-time clock and a micro SD card. So you can build a whole project on that. And this one also makes use of what are called pogo pins. You can see them under here. They're pressing up and they're going against the bottom of the XIAO so they can expose some of the connectors over there. And they actually bring them out over here. So this is a great way to experiment with the XIAO without having to use a solderless breadboard or anything. And again, these are just a few of the many different accessories that Seeed Studio has for experimenting with the Seeeduino XIAO. Now, if imitation is the most sincere form of flattery, then the folks at Seed Studio should feel pretty flattered, because a couple of manufacturers have made boards that are compatible with the XIAO. They work with the same pinouts, they can be used with the same accessories. Let's go and finish off by taking a look at a couple of these. Now, a few manufacturers have XIAO-compatible boards. DF Robot, for example, has some of their Fire Beetle boards that have the same pinout as the XIAO. But one series that really stands out are the Adafruit Cutie Pie series, and they have a series of XIAO-compatible boards with different microcontrollers, including a couple of microcontrollers that Seed Studio doesn't have, such as the ESP32S2. Now, this is one that emulates the original XIAO, the SAM D51 board. It's the original Cutie Pie, and it's got a couple of extra things that the Seeeduino XIAO doesn't have. For example, over here we've got a quick connector on the end, and that's a really handy way to connect devices up. And so if you need a quick connector, you can get it there. It's also got a better reset button than the one on the XIAO. This is a physically better one and a lot easier to press. It's got the SDA and SCL labeled for I2C, etc. But it's the same pinout, the same form factors to XIAO. It uses a USB-C connector. It's got connections on the bottom as well, just like the XIAO does, including connections for SPI flash. And so if you want to try some alternative boards, but you want to get into the XIAO prototyping stuff, you can use these boards with it, and they will work perfectly. They have the same electronic specifications as the Seed Studio Seeeduino XIAO. Now, before we wrap up our look at the Seeeduino XIAO, I want to make one other point in favor of these boards. Not only are they inexpensive and high-quality boards, but they have excellent documentation. The Seed Studio Wiki has all the documentation that you would need in order to get any of these boards working in your project, and that really sets them above a lot of other manufacturers who make great products but don't really bother to document them. Seed Studio has actually done a great job of this. Now, if you want some more information about the XIAOs, or if you'd like to get some of the code that I used today, you'll find that all in the article that accompanies this video on the DroneBotWorkshop.com website, and there's a link below the video to that article. While you're on the website, if you haven't yet, please consider signing up for my newsletter. It's not a sales letter, it's just my way of letting you know what goes on here in the workshop, and sometimes I even give you a preview of my videos there. You can also join the DroneBot Workshop forums if you want to discuss the Seeeduino XIAO or anything electronic with a number of like-minded individuals. And there's information below the video for joining the forum as well. And of course, that's all free. And another thing that's free and fun to do if you haven't done yet is to subscribe to the YouTube channel. I make videos about microcontrollers, electronics, robotics, artificial intelligence. And if you're into that sort of thing, you'll probably like a lot of those videos. Subscribing is very easy to do. All you need to do is click on that red subscribe button and also hit the bell notification. And that way you will get notified every time that I make a new video. So until we meet the next time, please take good care of yourself, stay safe out there, enjoy playing with the Seeeduino XIAO, and I'll see you soon here in the DroneBot Workshop. Goodbye for now.